Hello friends, welcome to this channel, and after a long gap we are back, and in this session we are going to discuss about the configuration of Siemens decentralized busbar protection relays using Digsi 4 software. In this series of lectures, that is starting from today and in coming to 3 or 4 sessions, we will discuss about the configuration of Siemens decentralized bus bar units, that is the configuration of central units as well as the bay units. We will discuss about the configuration of inputs and outputs in the bay units, as well as how to draw the plants or how to draw the different types of bus bars in the central unit, how to link the different bay units in the central unit, the settings of the bay units which we have to configure inside the central unit, followed by the configuration of CFC and DR channels as per our requirements. So, like all our practical sessions on distance protection as well as the configuration of Siemens BCU, again I am using Digsi 4 software, and in this particular session I am using Digsi 4.94. However, the configuration using any of the Digsi software starting from 4.84 up to 4.94 is exactly the same. So it doesn't matter whether you are using Digsi 4.84 or Digsi 4.94. The steps and the concepts remains exactly the same, which I am going to discuss in this particular session. All the theoretical concepts related to the bus bar protection has already been discussed and are available on the playlist of this channel. And as you are aware that all the video on this channel are published in Hindi as well as English. So you can watch any session in any of these two languages based upon your requirements, based upon the comfort level. There is no difference between the concepts explained in the Hindi session as well as the concepts which are going to be explained in this English session. So now let us start with today's session. And if you see on this screen, this Digsi software is already open. So first, before starting this Digsi software configuration, just see this some of the basics, and these basics concepts are very simple. The Siemens distributed busbar protection, as you can see, we are going to discuss the configuration using Digsi 4 software. And in this distributed or decentralized busbar protection, there are basically two things. One is bay unit and another is central unit. In the bay unit, the Siemens relay, which comes under or falls under the bay unit category, are 7SS523 and 7SS525. These two relay or these two bay units, these two different models of bay unit, I would rather say, are SIP3 or SIPROTEC 3 series, and the central unit, that is 7SS522, is basically SIPROTEC 4 series relay. There is not much difference between the configuration of 7SS523 and 525. The configuration wise, the input output configuration wise, both these bay units are exactly the same. Only difference is in terms of the number of binary input output available between these two variants, and the availability of LEDs, number of LEDs which are available in 7SS523 and 7SS525 are different. Also, in 7SS523, you are having one HMI for the configuration for the viewing of measurements, while no HMI is available in case of 7SS525. Since these bay units belongs to SIPROTEC 3 category, so in case you want to do any configuration, in case you want to read anything from this relay, you have to do the configuration from the front port only using the Digsi 9-pin connector cable. Now, for this particular session, I am going to take an example of 1.5 breaker scheme, and I am considering 4 bays on each bus bar, that is 4 bays on bus bar 1 as well as 4 bays on bus bar 2. Then these 4 bays I have considered as 701357 on bus bar 1 and 702468 on bus bar 2. If you see here, these are the base connected to bus bar 1 and bus bar 2, and this is basically 1.5 breaker scheme wherein I have not shown the tie base because tie base are not connected to your any of the buses. That's why I am not going to consider the configuration of type A right now. I am going to consider only about the configuration of the main base which are connected to bus 1 and the main base which are connected to your bus 2. And this particular example 701357 are connected to bus bar 1 as well as 702468 are connected to your bus bar 2. Now this bus bar 1, the base which are connected to bus bar 1, it is called inside the relay as bus zone 1 or bus section 1. Similarly, the bays which are connected to bus bar 2 are called BJ2, that is bus zone 2, or BS2, that is bus section 2. You will be having the different differential and stabilization current for each bus zone, that is bus zone 1 and bus zone 2, and the overall check zone, which is the combined or the combination of version 1 and version 2 that you will also see inside the relay. I have already discussed what is the meaning of bus zone, what is the meaning of check zone. Everything we have already covered in the theoretical session, so I am not going to repeat all those things here again. So I am directly now moving to the configuration wherein we will take 8 bay units, that is bay unit 1, 2, 3, 4, 5, 6, 7, 8, and most importantly the odd number bay unit, that is bay unit 1357, will be considered in our example. Those bay units, that is odd number bay units, will be considered to be connected to bus bar 1. Similarly, the bay units which are the even number like BU2468 will be considered to be connected to your bus bar 2. So now moving to the Digsi software, what you have to do is create new project. So just click here, create, and like in the Hindi session, I have created this bus bar Hindi demo. So now I am creating this bus bar English demo. Then click on OK. And now if you see here, this is a folder in which you have to insert the 8 bay units and 1 central unit. So what I have to do, just right click, go to this device catalog, and in the device catalog you will see all the device drivers which I have already installed, and I will have to go to the 7SS, that is bus bar protection. Here I will go to the 7SS525, which is the bay unit that I am going to consider, and I will drag and drop the 8 bay units. So bay unit 1, and if you see the MLFB number over here 7SS525, then star 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 with one question mark, then star star star, and this is because these are a SIPROTEC 3 device. If you see here, this is SIPROTEC 3 device. The only important point or only MLFB digit which you can change is this position 13, which is related to the bay unit with supplementary function, that is the bay unit with overcurrent protection or without supplementary function. So I am considering without supplementary function, and then OK. Similarly, you have to drag and drop 7 more. So just keep on adding 7 more here. I am going to consider each bay unit as exactly the same. So this is my bay unit 3. So once you have dragged and dropped all 8 bay units, or once we have entered all 8 bay units, so the next thing we have to select one central unit. So the central unit, as you have already known, now this is 7SS522, and simply drag and drop one central unit. In the central unit, since this belongs to SIPROTEC 4 series, so you have to enter the MLFB number as per the number available on your relay. So suppose I am selecting this MLFB, and you can select any MLFB as per the available MLFB number on your device. So simply I have selected one MLFB number as per our requirement, and just OK. So now if you just click on any of the bay units and go to this right click and then object properties. First of all, what I have to do is just rename these bay units as suppose 701, 2, 3, 4, 5, 6, 7, 8. So this is 701 object properties, and likewise I will do for all the other bay units. So once I have renamed all these bay units, so now you can see just right click on any of the bay unit object properties and go to this communication parameters. Here you can see that the communication parameters is simply substation address, feeder address, and then device address. This is because this is SIPROTEC 3 device, and you will connect to your bay unit through this device number only. And if you see any other device, just this device number will keep on changing. So go to the second device, you can see here it is 2, and if you move all the way to 8, then you can see this might be 8. So this is 8. Now similarly you can see the communication parameters of your uh, 4 number device or Digsi 4 device, that is central unit. Uh, those that I'm not going to explain because this is exactly the same what we have discussed in distance relay as well as what we have discussed under the BCU configuration section. So now just double click on this MCU offline parameter configuration and OK. Once you have done this, it will open, and now it will take just few minutes, and once it is open, so now if you just double clicks on the settings, there you can see the substation configuration where you have to make this bus bar arrangement, that is the plant configuration, then the bay unit allocation and bay units. If you click on bay unit allocation, right now it is an empty window. Similarly, the bay units, if you click here, this is again empty, and these are empty because right now the central unit doesn't know how many bay units we have configured or how many bay units we have added. We have simply selected the bay units outside in our main project, but those bay units are not assigned in our central unit. Those bay units are not configured to any of the bays which are available. So you have to clarify to this relay that which particular bay unit or which particular bay unit, suppose bay unit 1, 2, 3, 4, 5, 6, 7, 8, which particular bay unit belongs to which bay, that I am going to explain now under this substation configuration. Just click, double click on the substation configuration and it will open. So now this is a new window over here. Right now if you see, this is simply a blank window with only this check zone. So just move this check zone over here, and now you are having one blank, fully blank window, you will say. So first, what I have to draw, I have to draw 2 bus bar. If you see here, I have to draw 2 bus bar 1 with 4 bays, that is 701357, and bus bar 2 with 4 bays, that is 2468. And then we have to assign, that is bay unit 1357 to bus bar 1 and bay unit 2468 to bus bar 2. So simply just click on this, which is for draw bus bar, and once you have selected this draw bus bar, just drag and drop to the desired position. Once you do this, now you will be having one differential and one stabilization current corresponding to this bus bar. Just place this over here and rename this. So I have to rename this bus bar. Suppose I am renaming this as bus bar 1, and then now suppose this belongs to your bus bar 1 belongs to bus section 1, so this is bus section 1 and you can select this color. Suppose this is red, this is user defined, so you can select any color, and now you want your measurement to be visible, so that's why I'm selecting this visible. No. Once you do this, this will be here, and I am simply going to drag and drop up to this point. If you see here, now this bus 1, it is written inside these 2 blocks also. Earlier these were with star marks. So now what I need, I will need one disconnector, one disconnector, one circuit breakers, and one seating for each bay. So if I am having 4 bays, so I will have 4 disconnectors, 4 circuit breakers, and for CTs. So 1.5 breaker scheme, you know that the CTs which are connected to bus 1, it will be connected to bus 1 throughout. Uh, because this 1.5 breaker scheme is not a reconfigurable bus bar like your double main or double main in transfer, in which your CT will keep on changing its assignment from bus 1 to bus 2 depending upon the position of the disconnector. So here I will select the permanent closed disconnector. Suppose this is a permanent closed disconnector 1 for the feeder 1. Then I will have one breaker. So this is one breaker. Then next is the CT. So there are two types of CT, one with CT top and another is CT bottom. This basically shows the CT star point. So suppose I have made the star point toward bus bar, so I will select this CT and now just drag and drop these two somewhere down for better look. Now select this interconnector or jointer and then just simply join it. The next thing that I have to do is I have to name this as suppose 702 or 701. So just select this A in the rectangle. Now right click object properties. Suppose this is your 701. So again this is 701. Now if you see here, it is again still star marks. So how it will change? Just select this CT, then right click object properties, and now I have to assign this CT to some bay, and this I know that this is 701 is assigned to bay unit 1. So simply I will assign this to bay 701 with short name as 701 and then this long name as 701 CT with bay unit as bay unit 1. Suppose I am using the CT ratio in the yard as 2000, so I will select this as 2000. So once you have done this, automatically you can see over here this is 701 CT with bay unit 1, which is for 701 bay. Once you have done this, it is now in the green color. So we will move to this breaker, go to this object properties and assign this breaker also to your 701 bay and just rename this to 701 52 and assign this again to bay unit 1. Next, this disconnector, right click, object properties, and then 701. I will assign this as 70189. So this is 70189, and then this is in unit 1 with disconnector 1. Similarly, for the second bay, what you need is again a one disconnector, one breaker, one CT with polarity towards your bus bar, and then drag and drop this box to this point. Basically this will show you the measurement of this particular bay. This 2 on the top, it will show the measurement of your bus 1 differential and stabilization current. Similarly the remaining two blocks, that will show you the now these two will show the check zone differential and stabilization current, and this will show the current of the particular feeder. So just join all this for your second bay, and this is very simple to join, not like DCU. So very simple, just join all this and select this text and place over here, and I will rename it as 703 for your first one second video. Now once you have done this, what you have to do, just click on CT, object property, assign to your page number 703, short name is 703 and the long name is your 703 CT, and I'm going to assign this to your bay number 3. And the CT ratio, suppose it is again 2000, so I will select 2000 and then OK. Next, over to breaker, object properties, just simply select 703 with short name, suppose it is 70352, so this is your 70352 and the bay unit as bay unit 3. Similarly, go to this disconnector, object properties and assign to bay, this is 703, name short, it is 703 suppose, and this is 70389, and now this bay unit is your bay unit 3. Likewise, we have to add two more. So again, I'm going to consider one disconnector over here. This is one disconnector with one circuit breaker and one CT also. First, just drag it over here, some here, and one CT. After this, I will need to drag this somewhere down and simply connect. Once we have done this, just take the bay unit name, insert bay unit name, and place over here, and just rename this. This is your 705. So this is 705. Just here, and now go to CT, right click, object properties. This will be assigned to your 705, and the short name is, you might write as 705 CT, or you may write 705 CT, or you can simply write CT. It is up to you. Now bay unit 5 and the CT ratio as 230. Similarly, go to this breaker, object properties, assign to bay unit. This is 705. Suppose this is 705, and now you can write it as 705. And next, assign this to bay unit 5, and then go to this connector. This connector is again 705 89, and it is assigned to your 70589, and then it will be assigned to bay unit 5. Similarly, I have to do for next bay, and that will be the last bay on bus bar 1. So I will select this connector with one breaker and one CT. Then I will just simply drag and drop over here, and I will connect all these. Once you have connected, the important point which you have to consider for this bus bar configuration, or this basically this how to create this substation configuration, or how to create these plants, the most important thing is this naming and this linking. So if you are not naming it properly, and if you are not linking it properly, then your bus bar might not work properly. The first important thing is that all these bays must be connected properly to your bus 1. If any of this connection is missing, then that the current of that particular feeder will not be read by this bus bar. The next important thing is this linking. So you must do this linking very carefully. Any mistake in this linking will lead to incorrect operation or the maloperation of your bus bar, and that might lead to large scale outages. So this configuration is very important. Now just simply keep on naming this as per your convenience, or as per the schemes available at substation. So now the last element is your isolator. Simply link this 70789. So now this is your 70789. Then bay unit, I will assign these to bay unit 7. And why I have done like this, that is, this is bay unit 1357, is because I have considered in this example that is the bay number 1 or 701 is to BU1, 703 it will be assigned to your BU3 or bay unit 3, 705 to bay unit 5, 707 to bay unit 7, for better understanding only. Once you have done this, or once you have configured this for bus 1, the next thing is you have to draw this exactly same thing for bus 2 also. So we can draw everything over there, or the second thing is that you can directly copy and paste this and use as per your convenience. So just select everything, Control C, and just come to this page, that is page 2, place here, and then Control V. Control V and then enter. So now you will be having this. Just keep doing like this. What you can do next is you can just move these two blocks, this one block and this second block here. Now if you see right now, there is nothing written inside these two block of differential and stabilization current, because this relay know that this differential and stabilization block is for bus 1, but for bus 2 I have not defined anything. So first you have to rename this as and assign this as bus 2. So simply suppose this is your bar 2, or and you in the long 2, and now this will be assigned to your bus section 2, and suppose I am using this green color. Okay, now you can see this is the bus 2 differential bus 2 stabilization current. Next thing, I have to assign these CTs of the feeder 1, 2, 3, 4, 5, 6, 7, 8 as per our example. So this bus bar 2, these CTs will be for this feeder 702, 704, 706, 708. So first you have to rename all these. So suppose this first is 702. So simply put it as 702. And the next one, it is your 704. So I will rename it as 704. And the next one, it is 706. So I will rename it as 706. And the last one is 708. So I will rename it as 708. So the important thing is still these blocks are reading the current with the name 701, 702, 701,357. So how you have to do is just select any CT of suppose 702 bay, right click, go to object properties, and then assign this CT to bay, and this will be assigned to your bay number 702. And the 5 written inside basically designates your fifth bay starting from the 4 that we have already added, that is 701,357. Then just rename this as 702. Again rename this also as 702 CT, and then assign this to bay unit 2. Once you assign, now you can see the current will be from this 702 bay. Go to breaker, again object properties, assign to bay. So this will be assigned to bay number 702 and assigned to bay unit 2. Okay. Then go to this disconnector, right click, object properties. I have to assign it to 702 bay, and this suppose this is your 70289. So simply change its name and designation and assign this to bay unit 2 and OK. So you have done this for 702. I have to do everything exactly same for 704, 6 and 8 way. Right click, object properties. First you have to assign this as 704. So I have to assign this as 704 CT. So just keep on doing the same work. Now this is your unit 4. Then for the breaker, object properties and assign to bay, this will be bay unit 4. This is 4. This is 4, and in the end this is unit 4. Then go to disconnector, object properties, and this will be your 704. Suppose this is your 70489, assigned to bay unit 4. Okay. Now moving to the next, that is 706. Select this CT, object properties, assigned to bay, and this will be your bay number 706, and just rename these two as 706 CT and assign these to bay unit 6. Next, the breaker, object properties, assigned to bay, and this is very important. I will assign this to bay number 706, then rename this as 706, and finally this will be your bay unit 6. Similarly for disconnector, right click, object properties, assign to bay unit, this will be 706, and rename this as 706 and 70689. Bay unit, it will be bay unit 6, and then it is done. Now for 708, just right click, object properties, assign to bay. This will be your 708. Rename it as 708. Name it as 708. Assign these to bay unit 8, and OK. Now the last element is this disconnector. So right click, go to object properties, and assign simply this 708, and rename this. So next thing, simply this will be indicate. Now, if you see this configuration, this is very easy once you understand the concepts. And the important point while doing these configurations are how you are linking your bay units to this bus bar, the plant configuration or the plant that you are making over here. You have to link every bay unit very carefully. You have to name these cities very carefully. You have to select the city polarities very carefully. Otherwise, this relay is prone for maloperation, because if the bay units are not properly selected or the city start point is not properly selected, then it will maloperate or not operate correctly. Then you once you have done everything, just go to chart and then save. Once you save, you will see this normalization current. The normalization current is very important in case of Siemens bus bar. So, we can set any normalization value, 1000, 2000, 3000, 4000, anything. But the important thing is we have to select the normalization current, either the largest of all configured transformers. So since we have configured everything at 2000, so you can select either 2000 or you can select any normalized value. If you select any normalized value, suppose 3000, then all the currents of every bay will be normalized to that value, and your settings, that is the settings of your LBB protection or the breaker failure protections, bus bar protections, the monitoring protections, that is your city supervisions, all those will be in terms of this normalized value of current only. So in this particular case, I will select it at 2000 and OK, and finally I will save once again. Once you do this, this configuration of your bus bar or 1.5 bus bar scheme with 4 bays on bus 1 and 4 bays on bus 2 up to this plant model or up to the substation configuration model, it is completed. In the next session, we will see how to link those bay units which we have added in the beginning of this session inside your central unit. How we tell this central unit, that is which bay unit belongs to which particular base or which particular feeder. All those things we will discuss in the next session, and then in the coming sessions, we will also discuss how to configure the inputs and outputs in your bay units. What are the meaning of different types of settings or different settings inside your central units? Everything will be discussed in each and every sessions, followed by this particular session. I hope the concepts which are explained in today's session is clear to all of you. And once you do the practice with your own, once you install this software in your relay, in your laptop, sorry, and you start practicing, and then you are or then you will get the maximum benefit through these videos and through these tutorials. If you are not practicing with me, then there is a chances that over a period of time you are going to forget what I am explaining in these sessions. So keep on practicing on your laptop with any of the schemes of your substation, or you can practice the same scheme which I am going to discuss in these coming sessions. You can practice the same things, and once you practice and once you understand these concepts, then it will be very easy, and you can apply these concepts at your organization, and you can learn about various different things in the Siemens decentralized busbar relay. And over the period of time, if you keep on practicing, if you keep on doing what I am explaining in these tutorials, then definitely it will be very beneficial to you. In the end, if you like this video, if you like the contents, then you may share this video with your friends so that more and more people can understand these concepts, and more people can apply these concepts at their organizations. So we will meet again with in continuation with this series. Till then, thank you and goodbye.